Okay. In this lecture, I am going to discuss what is pH and how to calculate pH for different solutions. Okay. First of all, when we should use the concept of pH. Remember, whenever H plus ion concentration, okay, molar concentration, if it is less than or equal to 1, then only we use the concept of pH. Okay, so pH is applicable only when solution contain H plus ion concentration less than 1. That means very low concentration. Okay, so only in very low concentration or low concentration we use the idea of pH. Right? Now, pH, the definition of pH is this. pH is defined as negative common logarithm of activity of H plus ion. This is the a definition of pH, where AH plus is the activity of H plus ion. Is the activity of H plus ion. What is activity? Activity is directly proportional to molar concentration of the substance. Activity is directly proportional to molar concentration. They are not equal actually. Activity is equal to activity coefficient into concentration. This is the relation between activity and the concentration. Since we are going to use the concept of pH for low concentration or dilute solutions, okay, low concentrations. In low concentration, we can assume this gamma, that is activity coefficient, as 1. Therefore, for pH calculation, right, often, okay, not often, most of the time, we are going to use, right, or almost all the time, we are going to use concentration instead of activity. Okay, because I am going to assume that activity coefficient is as 1. Therefore, this pH relation can be written as negative logarithm of base 10 molar concentration of H plus ion. This is the relation we are going to use to calculate pH of a solution. So if you want pH, okay, you must know the molar concentration of H plus ion. So this is nothing but molarity, concentration of H plus ion in molarity. So molar concentration of H plus ion in solution. Okay, so if you know molar concentration of H plus ion, substitute that value here and you can calculate pH. Now, actually, this H plus concentration, okay, it is actually called total H plus concentration. Total H plus concentration means H plus which is available from the acid. If you use acid, you should find out H plus from acid. If you use base, you should find out OH minus actually. But let me start with acids first. So for a given acid, total H plus concentration is nothing but H plus concentration from acid plus H plus concentration, hydrogen ion concentration from water. Alright, this is water. Because water will also undergo partial ionization, right? Therefore, we should include the H plus ion that is obtained from, produced from water, right? So total concentration here, we should use only total concentration. This is total concentration which we say. Okay, this concentration is the total concentration. Total concentration equal to concentration of H plus ion from acid and concentration of H plus ion from water. Now, suppose if H plus ion concentration is sufficiently high. Okay, let me use here. If H plus ion concentration from acid, okay, if it is greater than 10 power minus 6 molarity, right? This is I'm going to use this condition at a temperature of 25 degrees Celsius. Why 25 degrees Celsius? We'll discuss that. But before going to that, let me introduce this. Right? If H plus ion concentration from acid, if it is greater than 10 power minus 6 molarity, in this case, you can neglect the H plus ion concentration from water. So we can neglect H plus ion concentration from water can be neglected. So whatever acid is given, calculate H plus ion concentration from acid, okay, and see the value. If the value is greater than 10 power minus 6 molarity, then you need not worry about H plus from water, right? You take only the H plus from acid and calculate the pH, right? Similarly, if H plus ion concentration, from acid, okay, if it is very low, okay, if it is less than say 10 power minus 8 molarity, 10 power minus 8 is very low. If the H plus ion concentration from acid, if it is very low or if it is very less compared to 10 power minus 8 molarity, then you can neglect H plus ion concentration from acid. This can be neglected. Okay, then you can use H plus ion from water to calculate the pH of the solution. Okay, so keep these two conditions which are very important, right? In general, if you want to calculate pH of a solution, okay, you should calculate the total H plus ion concentration. That means H plus from acid, H plus from water, add the two value and substitute that value here and calculate the pH. That's the idea. But under this condition, if H plus from acid is greater than 10 power minus 6 molarity, in this case, you can neglect H plus from water. And the second condition is, if H plus from acid is very low, if it is less than 10 power minus 8 molarity, then you can neglect H plus from acid. Okay, you can use only H plus from water. Right? Yeah, keep this in mind. We are going to utilize these conditions while calculating pH per solution. Right? Then now we'll discuss before going to calculate pH of solutions. Right? Let me take water as the solvent first. Okay, even you can calculate pH in ethanolic solution, right? You can calculate pH in ammoniacal solution. You can take any solvent actually, but we are going to calculate pH, right? Mainly in aqueous solution. Therefore, that's why while saying H plus ion concentration here, I took water concentration, H plus from water, because I am assuming that the solvent is water here. But keep this in mind, the solvent need not be water. It can even be ethanol. It can even be ammonia. Okay, so depending upon the solvent, right, you should find the H plus from solvent. Right, and this is applicable for aqueous solution. Right, total H plus equal to H plus from acid and H plus from water. This relation is applicable only for aqueous solution. Right, now what I'm going to do, if you use aqueous solution, then you should consider the ionic product of water. So let me just discuss about ionic product of water. Ionic product of water, okay, which we represent as Kw. What is ionic product of water? We know very well, water molecule will undergo self-ionization. Okay, so let me write like this. This is liquid water, which will ionize us to give H plus ion in aqueous medium and OH minus ion in aqueous medium. Okay, so this is how water molecule dissociate in water, pure water. Okay, in pure water, students observe carefully. In pure water, concentration of H plus ion and concentration of OH minus ion are the same. They are same. Okay. Therefore, now since there is an equilibrium, okay, exists, and that equilibrium constant depends on temperature. Right? Suppose if I take the temperature as 25 degrees Celsius, right, at 25 degrees Celsius, right, at 25 degrees Celsius, let me write the equilibrium constant expression as Kw equal to, okay, let me write just K first. K is equal to molar concentration of H plus ion into molar concentration of OH minus ion whole divided by molar concentration of water. Okay, and in pure water, the molar concentration of water is how to calculate molar concentration? Mass by mass of substance or number of moles per liter. Okay, so per liter of water, let us assume density as 1. So per liter of water weight is 1000 gram. 1000 divided by 18 will give you number of moles. So we have 1000 grams of water in 1 liter divided by 18 is the molecular weight. So this will give you number of moles in 1 liter. This is nothing but equal to 55.55 moles. Mole per liter. So the concentration of water, pure water, is 55.55. Okay, whereas the concentration of H plus ion and concentration of OH minus ion, which is actually obtained through this dissociation, which is extremely low compared to this value. Therefore, you can assume that the concentration of water is practically constant. Okay, if this is constant, then this constant into this constant will give you a new constant. Let me write that constant as Kw. So Kw is equal to concentration of H plus ion into concentration of OH minus ion. Okay. At 25 degrees Celsius, this value was found to be, okay, experimentally it was found, and the value is 1 into 10 power minus 14. Let me write in the next page. At 25 degrees Celsius, the value of Kw was found to be equal to 1 into 10 to the power minus 14 mole square per liter square. This is the value of Kw at 25 degrees Celsius. Okay. So if I use this value, right, if I use this value here, then see, concentration of H plus ion into concentration of OH minus ion equal to 1 into 10 power minus 14. And I have told you in pure water, H plus concentration, OH minus ion concentration are exactly same. Therefore, I'll keep this H plus as such, and in the place of OH minus, I'll put H plus. So I'll get H plus into H plus, so I'll get H plus square equal to 1 into 10 power minus 14. Or concentration of H plus ion equal to, we should take square root. If you take square root, you'll get 1 into 10 power minus 7 mole per liter. This is the H plus ion concentration. This is the H plus ion concentration in pure water at 25 degrees Celsius. Okay, this is at 25 degrees Celsius. At 25 degrees Celsius, the H plus ion concentration is 1 into 10 minus 7 mole per liter. And what about OH minus ion concentration? Yes, in pure water, H plus and OH minus concentrations are same. Therefore, OH minus ion concentration also 1 into 10 power minus 7 mole per liter at 25 degrees Celsius. Okay. Then, what is the pH of pure water? So pH of pure water equal to at 25 degrees Celsius. Okay, you know the formula, minus log base 10. Concentration of H plus ion. H plus ion concentration now it is 1 into 10 power minus 7. Okay, or just 10 power minus 7. You can write this as negative log base 10 power minus 7. Okay, apply power rule. So minus or minus become plus. So 7 into log 10 base 10 value is 1. So pH is 7. So for pure water, pH is equal to 7 at 25 degrees Celsius. Don't forget that. Temperature is very, very important. At 25 degrees Celsius, the pH of pure water is 7. Okay? Then, now, let me just introduce the pH scale. pH scale at 25 degrees Celsius. Okay, what is the pH scale at 25 degrees Celsius? The lowest value of pH, okay, is actually 0. The lowest value of pH, let me just draw a line here. This is value of 0, and here the value is 14. This is the pH range at 25 degrees Celsius. Right? So here from left to right pH increases. pH increases from left to right. Okay, and this value, which is 7, pH 7 corresponds to pure water. Okay, if you have pure water at 20 degrees Celsius, pH should be equal to 7. Okay, so this is, we say that it is neutral. It is neutral pH. Suppose if you take any solution, if you dissolve any acid in water, or if you dissolve any base in water, then the pH will change. If pH value exists below 7, okay, from 0 to 7, we call those solutions as acidic solutions. Acidic. If the pH value is above 7 or between 7 and 14, then the solution is called a basic solution. So whether a solution is acidic, basic or neutral, that all depends on the value of pH. And remember, the value of pH depends on temperature. Okay, why I am telling this? This is very important. See, suppose you take a pH scale, right, at some other temperature, say at 15 degrees Celsius, for example. At 15 degrees Celsius, the pH range, right, is not actually 0 to 14. It is actually 0 to it is some point 14.36. The value will change. pH range is not 14, it is 14.36, and the middle value is 7.18. Okay, therefore pH scale will change. So suppose at 25 degrees Celsius, suppose if I say at 25 degrees Celsius, pH of a solution is 7.1. Is this solution basic or acidic or neutral? Listen, as per this data, okay, if it is 7.1, it should be a basic solution. Okay, but this pH is given at 15 degrees Celsius. At 15 degrees Celsius, 7.1 is below 7.18. Therefore, the solution is acidic. Therefore, you should be a little careful while calculating the value of pH. Okay, and you should note the temperature actually, right? But nowadays, in most of the calculation, right, we assume temperature as 25 degrees Celsius, right? For other temperature, they'll mention the temperature. But if temperature is not mentioned, you can assume that the temperature of the solution is 25 degrees Celsius. Okay, yeah, keep this in mind. Then, actually, as the temperature increases, what happened to the pH scale, pH range, right? Suppose if the pH range, right, this is 0, Suppose if the pH range is 0 to 14.36, right, at 15 degrees Celsius. Then if you go to 25 degrees Celsius, the pH range actually decreases, right? pH range decreases 0 to 14 at 25 degrees Celsius. This is at 25 degrees Celsius. If we increase the temperature further, right, say if I go to 40 degrees Celsius, right, at 40 degrees Celsius, the range further decreases. So keep this in mind. As the temperature increases, okay, pH range decreases. Or we can see the other way, as temperature increases, pH of the solution decreases. As temperature increases, pH of the solution decreases. Okay, so keep this in mind. This is very, very important. But we are going to do calculations, right, based on the assumption that the temperature of the solution is 25 degrees Celsius. Okay, so you should keep this in mind. This is very, very important. Okay, while calculating pH, you should remember the temperature. Okay, at what temperature you are working, or at what temperature you are calculating the pH of the solution. Okay, now so I have introduced what is pH and what is the ionic product of water and what is the pH scale. Okay, now what is the degree of dissociation of water at 25 degrees Celsius, right? What's the value of alpha? Alpha at 25 degrees Celsius. In the case of pure water, degree of dissociation of water molecule or water at 25 degrees Celsius. Okay, yeah, you know very well water dissociate to give H plus and OH minus. Plus. Okay, suppose if we take 1 mole initially, let us assume that from 1 mole alpha mole dissociate. So you will have 1 minus alpha mole remaining, and here we will get alpha mole, here we will get alpha mole. So this is initially I am taking 1 mole of water, and from 1 mole let us assume that alpha mole is dissociating. So if alpha mole of water molecule dissociate, I will get alpha mole of H plus and alpha mole of OH minus. Suppose if the for 1 mole, okay, we have some concentration. Let the concentration be C. Okay, concentration is C. If the concentration of water is C, then 1 minus alpha into C and alpha into C. These are the equilibrium concentrations. Okay, now what is the concentration of H plus ion? So concentration of H plus ion equal to alpha into C. Right? At 25 degrees Celsius, we know very well. Okay, we have calculated the concentration of H plus ion, which is 1 into 10 power minus 7 equal to alpha into concentration of water. Suppose if we take 1 mole of water, if it is present in 1 liter, 1 mole, okay, in 1 liter, then this concentration become 55. I'm sorry, concentration of water. We know very well 1 liter water weight is 1000 gram, assuming density as 1. So 1000 by 18 will give you 55.55. So 55.55 is the concentration of water. Okay, then alpha equal to degree of dissociation equal to 1 into 10 power minus 7 divided by 55.55. This is the degree of dissociation of water at 20 degrees Celsius, which is very, very low value. Keep that in mind. It's a very, very low value, right? Yeah. Now, so this is the degree of dissociation of water at 25 degrees Celsius. Now, okay, how to calculate pH for a solution? Okay. While calculating pH of a solution, first of all, you must know which compound is given, whether it is acid or a base, strong acid, weak acid, everything you should know. Okay, first what I'm going to do, I'm going to show you how to calculate pH for strong acids. So let me take a pH of strong acid, pH of strong acids. How to calculate pH of strong acids? What is meant by strong acid? Strong acid is one which will undergo complete ionization. Complete ionization. It's the meaning for strong acid. Okay. So if I take HCl, one molecule of HCl, if I put it in water, it will dissociate to give H plus ion and Cl minus ion. If you put 100 molecule, all 100 molecule will dissociate. If you put 1000 molecule, all 1000 molecule will dissociate. Okay, so one molecule of HCl will give one H plus ion. If I take sulfuric acid, H2SO4, right? Assuming it undergoes complete dissociation, so I'll get two H plus ions, right, and the sulfate ion. Okay, so in the case of strong acid, since they undergo complete ionization, okay, you can calculate H plus ion concentration from acid directly from the concentration of the acid. Okay, what I'm trying to say? See here one molecule of HCl will give one H plus. Therefore, concentration of H plus ion in solution is equal to concentration of HCl. Okay. Whereas here one molecule giving 2 H plus ion. Therefore, concentration of H plus is twice the concentration of sulfuric acid. So in this case, H plus ion concentration is twice the concentration of the acid. And remember, here we are using only molar concentrations. Okay? Yeah. Now, so how to calculate pH of solution? So, right? So let me just use some example. Okay. Number one, calculate the pH of say 0.01 molar hydrochloric acid solution. Okay, calculate the pH of 0.01 molar aqueous HCl. So that you should keep that in mind. You should keep in mind that the solvent is water here. Yes, how to calculate pH? Since HCl is a strong acid, see the substance first. See the compound first. HCl is a strong acid, so it will undergo complete ionization. Right? So for HCl, as I told you before, H plus ion concentration is equal to the acid concentration. Acid concentration is given here, 0.01 molarity. Therefore, H plus from acid, okay, this is H plus from acid equal to 0.01 molarity, which can also be written as 10 power minus 2 molarity. 10 power minus 2 molarity is very much greater compared to 10 power minus 6. Okay, therefore you can neglect H plus from water. You can neglect H plus from water, right? Therefore, in this case, you can calculate pH as pH equal to negative logarithm of base 10 H plus ion concentration from acid alone you can consider. Okay, so which is nothing but minus log base 10. H plus from acid is 10 power minus 2, so it is 10 power minus 2. Okay, and if you bring this minus 2 in front, minus or minus become plus, so you will get the value as 2. Sorry, so pH of the solution is 2. And remember, the temperature is 25 degrees Celsius. Though it is not mentioned, okay, you should keep that in mind. If the temperature is not mentioned, assuming the temperature is 25 degrees Celsius, you should assume like that. Okay. For other temperature, they will mention. For 25 degrees Celsius, usually people won't mention that. Okay. Then. Next one. Suppose if the concentrations are given in normality, then what to do? You have to convert normality into molarity. Okay. Say for example, I'll take another problem. Calculate the pH of 5 into 10 power minus 3 molar sulfuric acid, aqueous sulfuric acid solution. Calculate the pH. Right? Now how to do that? So now concentration of acid is given, but you know very well sulfuric acid is a dibasic acid which will undergo complete dissociation and gives 2H plus ion and SO4 2 minus ion. So each molecule will produce 2H plus. Therefore, in this case, concentration of H plus, right, is equal to from acid. Right? Concentration of H plus from acid is equal to twice the concentration of the acid. Twice the concentration of the acid. What's the concentration of acid given? 5 into 10 power minus 3. So 2 into 5 into 10 power minus 3, which is nothing but 5 into 2 is 10. 10 into 10 power minus 3 is again 10 power minus 2 molarity. 10 power minus 2 is very much greater compared to 10 power minus 6 molarity. Therefore, you can neglect H plus from water. So, pH of the solution equal to, in this case, pH equal to negative log based on concentration of H plus from acid alone you can use. Okay, so negative log based on concentration of H plus is 10 power minus 2. Again, the pH of the solution is 2. Okay, so whatever acid is given, you just see whether the acid is a strong acid, okay, and whether it is a monobasic or dibasic or tribasic, right? Okay, note that, and based on that you do the calculation. Okay, now suppose if the concentration of if the solution is given like this, you calculate the pH of 10 power minus 7 molar aqueous hydrochloric acid. Okay, 10 power minus 7 molar. Right? Now, for HCl, each molecule will give 1 H plus ion. Therefore, concentration of H plus from acid is equal to concentration of the acid itself. Okay, is equal to concentration of the acid, which is nothing but 10 power minus 7 molarity. Okay, but now H plus from acid is very, very low. See, this value is less than 10 power minus 6 molarity. So you should be careful now. What we should do? We should include H plus from water. Okay, so we should include H plus from water. How to do that? Okay, so what I'm going to do, you know very well, Kw is equal to concentration of H plus into concentration of OH minus. Okay, then water will ionize to give H plus ion and OH minus ion. Okay, let us suppose the H plus ion concentration, right, from water, let it be say, okay, let us assume that in this solution 10 power minus 7 molar HCl, okay, water molecule dissociate and gives some number of H plus ion, say X, okay, or some moles of H plus ion. So you know very well, H plus from water, H plus from OH minus, they are same. Plus we have H plus from acid that we have to include. Okay, so concentration of H plus ion in solution is concentration of H plus from water, that is X, plus 10 power minus 7 is the concentration of the H plus ion from acid. Okay, if you multiply these two, that should be equal to Kw, and you know very well, at 25 degrees Celsius, the value of Kw is 10 power minus 14. Therefore, you can write this as X square. Let me write here X square plus 10 power minus 7 into X. Okay, and I'll bring this to the left hand side. 10 power minus 14 equal to 0. Okay, we got a quadratic equation. Okay, if you solve this equation, you will get the value of X. X is nothing but concentration of H plus from water. Okay, yes, how to do that? You know very well, X is equal to, here the value of A is 1, A value is 1, B value is 10 power minus 7, C value is 10 power minus 10 power minus 14. A value 1, B value 10 power minus 7, and C value is minus 10 power minus 14. And you know the formula, x is equal to minus B plus or minus square root of B square minus 4AC over 2A. Okay, I'll use this formula and I'll calculate the value of x. X is equal to B value is 10 power minus 7, so minus 10 power minus 7 plus or minus square root of B square. If I take square of this value, I'll get 10 power minus 14 minus 4 into A value is 1 into C value is minus 10 power minus 14. So this will become minus or minus become plus 10 power 14 minus 14 divided by A value is 1, so divided by 2. Okay, and this will give me minus 10 power minus 7 plus or minus I'll take 10 power minus 14 as common, so I'll get here 4, here 1, so 1 plus 4, okay, I'll get 5 into 10 power minus 14 divided by 2. Okay, and you know very well square root of 5 is 2.236, so let me write the next page. So x is equal to minus 10 power minus 7 plus or minus root of 5 is 2.236, okay, into square root of 10 power minus 14 is 7, 10 power minus 7 whole divided by 2. Okay, we have two possible values, 10 power minus 7 plus 2.236 into 10 power minus 7. This is one possible value divided by 2, or you can take other value minus 10 power minus 7 minus 2.236 into 10 power minus 7 by 2. I'll get negative value here. This is not allowed. Okay, H plus from water cannot be negative. Therefore, I'm not going to consider that value here. Okay, and here I'll take 10 power minus 7 as common. Therefore, I'll take 10 power minus 7 as a common value. Here I'll get plus 2.236, and here I'll get minus 1 divided by 2. Right? If I subtract, I'll get 2.236 minus 1. So if I subtract, I'll get 6321. So 1.236 by 2 into 10 power minus 7. If I divide this value by 2, I'll get 0.618 into 10 power minus 7. Okay, or we can write this as 6.18 into 10 power minus 8. Right? This is molarity. This is the value of X. This is the concentration of H plus ion. Okay, from water. Now I am going to include this value here. Okay, therefore, what is the total concentration of H plus? Let me write in the next page. So, total concentration of H plus, total concentration of H plus equal to H plus from acid plus H plus from water. Okay, H plus from acid is 10 power minus 7. Okay, that value is available already. It's 10 power minus 7. H plus from water we have calculated. The value is, since this is in 10 power minus 7, okay, I will also use the same 10 power minus 7 value. Okay, so here this 0.618 into 10 power minus 7. 0.618 into 10 power minus 7. If I take 10 power minus 7 as common, and if I add, I'll get 1.618 into 10 power minus 7. This is the total concentration of H plus ion, okay, in the solution. Now, if we calculate pH using this, pH equal to negative common logarithm of total concentration of H plus ion, which is nothing but this value. If we substitute this value here, log base 10 1.618 into 10 power minus 7. This you can write directly as 7 minus log base 10 1.618. Okay, so log 1.618 is roughly 0.0 2 or 3 it will come. Okay, so the value will be equal to 6 point something, close to 6.8 like that, roughly. Roughly it is equal to 6.8 something. Okay, so you can calculate the pH for a dilute solution using this idea. Often what people will do is that just by seeing the value, calculate the pH of 10 power minus 7 molar HCl, right? They will put this value directly in the formula and they will say that pH equal to 7. pH equal to 7 means at 25 degrees Celsius, pH 7 is nothing but neutral solution. But the solution given is hydrochloric acid. Whatever dilution you do, acid remains acid solution. Acidic solution remains as acidic. It cannot be neutral. Okay. Therefore, pH is not 7. pH is actually close to 7. But the value is 6.8 or it will come 6.8 something. Okay. This is how you must do, you must calculate pH of very dilute solutions. Okay. If acid is given as a dilute acid, you can use this idea. Okay, yeah. Then. Now, we'll do one more problem here. Problem number 4. Yeah. Calculate. The question is compare the pH of compare the pH of say 0.01 molar 0.01 normality aqueous HCl and 0.01 normal aqueous sulfuric acid. Compare the pH of 0.01 normality, normal aqueous HCl, 0.01 normal aqueous sulfuric acid. Students, this is very, very important question. If it is given in normality, okay, see the acid. The acids are strong acids. If they are strong acids, okay, and have same normality, then H plus ion concentration must be same. Okay, so in this case, H plus ion concentration, let me write here. So in the case for 0.01 normal aqueous HCl, okay, concentration of H plus in molarity, okay, concentration of H plus. Listen, for HCl, N factor is 1. Therefore, normality and molarity are one and the same. So 0.01 N HCl is nothing but 0.01 M HCl. Okay, because N factor is 1. Right? So, and each molecule of HCl will provide 1 H plus ion. Therefore, concentration of H plus ion is nothing but the concentration of the acid. 0.01 molarity. Now, if I take 0.01 N aqueous sulfuric acid, students observe carefully. Often students get confusion here. What they will do, since each molecule will provide 2H plus, they will take 0.02. But the value is given in normality. You know very well, normality is nothing but molarity into N factor. Okay, and normality given is 0.01. So we need to find molarity of the acid first. Molarity equal to N factor. Sorry, N factor for sulfuric acid is 2. Say if I substitute this value, I'll get M is equal to 0.01 by 2. This is the molarity of the acid. And we know very well, each sulfuric acid molecule will provide 2H plus ion. Therefore, molar concentration of H plus is twice the concentration of the acid. Concentration of acid is 0.01 by 2. 2 get cancelled. So I'll get again 0.01 molar. So what I'm trying to tell is that if it is given in normality, see the acid, whether the acids are strong acid or not. If they are strong acid, whatever may be the acid, if they are strong, suppose, if two acids are strong acids, don't worry about the number of H plus and all. They will give same molar concentration of H plus. Okay, that means you calculate H plus from monobasic acid. The same value you will get for the other acids also. Okay, therefore pH of this solution for HCl, pH is 2. This is 10 power minus 2. If I put 10 power minus 2, it's a very high value compared to water. Therefore, you can neglect water concentration. Or H plus from water you can neglect. If I put 10 power minus 2 in the formula, I'll get pH equal to 2. Okay, and here for sulfuric acid also H plus is 0.01. Therefore, pH is also equal to 2 in this case. So you can calculate the pH, okay, whether it is given in normality or molarity using this idea. Okay, and remember, if the two acids given are strong acids, if they have same normality, then they will have same pH. This is the point you should keep in mind. Okay, this is how you must do pH calculation for strong acids. Okay, what we have to do for strong base? Yes, let me write here. For pH of strong base. For strong base, what we have to do? The idea is similar, but instead of H plus, we should calculate OH minus. That's all. Okay, see, sodium hydroxide, barium hydroxide, potassium hydroxide. Lot of examples are there. Okay, there are many examples available for strong bases. Okay, sodium hydroxide will ionize to give Na plus and OH minus. N factor is 1. For barium hydroxide, you will get Ba2 plus ion and 2 OH minus ion. They undergo complete ionization. Here N factor is 2. Okay, see, in this case, concentration of OH minus ion is equal to concentration of the base given. And in this case, concentration of OH minus ion is equal to twice the concentration of the base. Okay, if base concentration is 1 molarity, then this should be 2 molarity also. Okay. For basic solution, what we should do? We should calculate concentration of OH minus ion, and using that you can calculate the pH. POH, I'm sorry. After knowing POH, you can calculate the value of pH. Because we know very well, at 25 degrees Celsius, pH plus POH equal to 14. Okay. So, if you know the value of POH, you can calculate the value of pH from that. Okay. So, how to do that? Let me carry out one calculation here. Calculate the pH of 0.05 molar sodium hydroxide, aqueous sodium hydroxide. Temperature is not given, that means temperature is 25 degrees Celsius. Okay, now just how to calculate pH, but the substance given is a base. Therefore, first you calculate POH. Then using this formula you calculate pH, that's all. Right? And here sodium hydroxide is a strong base, it will undergo complete ionization. One molecule of sodium hydroxide provides 1 OH minus ion. Therefore, for sodium hydroxide, concentration of OH minus ion is equal to concentration of the base, concentration of the sodium hydroxide, which is nothing but 0.05 molarity, or I can write this as 5 into 10 power minus 2 molarity. Okay. Now, what is the value of POH? POH is equal to negative common logarithm of concentration of OH minus. OH minus concentration, and yeah, this is very important. I got that. This is concentration of OH minus from the base. From the base. Okay, which is very much greater compared to 10 power minus 6 molarity of base concentration or hydroxide concentration from water. Okay, it is very much greater. Therefore, I can neglect OH minus ion concentration from water. This we can neglect. Okay, therefore I can consider OH minus ion from base alone. Substitute this value here, 5 into 10 power minus 2. Okay, and if you calculate, I'll get 2 minus log 5 less than 2 minus log 5 is 0.69, I think so. Okay, roughly 0.7, so it will come out as 1.3, 1.3 roughly. Okay, that's the POH of the solution. Once you know POH, yes, you can calculate pH. How? Use this formula. Substitute 1.3 here and bring the 1.3 to the right hand side, so you will get the POH pH of the solution. So POH is there. To calculate pH equal to 14 minus POH value. POH value is 1.3, so 14 minus 1.3 will get 12.7. This is the pH of 0.05 molar sodium hydroxide solution. Okay, so you can calculate pH for strong acid, pH for strong bases using these ideas. Right? Now, suppose sometimes they will give mixture of two acids. Okay, or mixture of two bases, or a mixture of an acid and a base. Okay, in those cases, how to calculate pH. Right? Those things we'll discuss in the next class. Okay, I stop here. We'll continue. Thank you. Thank you for listening.